Now we're going to look at some other features of polygons. Polygons really have several properties that we're going to look at. We've already seen the angle measures, right? We talked about the sum of the angles for different size polygons. Two other properties that polygons have are the distance around the outside that we're going to call the perimeter, and the amount of space on the inside that we'll call the area. First, we'll talk about the perimeter. Area gets its own section. The perimeter is the distance around the outside, and we find that by adding up the lengths of each side. So if we know the lengths of all these sides, we simply add them up to find the perimeter. Now, some polygons, like this odd-shaped six-sided polygon, there's not really a nice formula or nice trick to doing this. You just have to add them up. You have to know them all and add them up. And so if you had something like 8 inches, 3 inches, 12 inches, and maybe this is 7, and this is, I don't know, I'm throwing some numbers in there, maybe another 8 and another 7. There they are, something like that. And so this is a six-sided figure, so I've got 6 sides to add up. And when I add these things, I try to pair them up in ways that make 10. It's a lot easier, in my opinion. So I like the 3 and the 7 there, that makes it 10. I like the 8 and the 12, that makes it 20. So 3, 7, 8, 12, I only have these two left. 8 and 7 makes it 15. And then I can add those up. That's 30, 45. So it's a 45-inch perimeter. Okay, so it's simply just adding up the sides. Now, that seems great if you have all of the side lengths. But the question is, what happens if you don't? And on a figure like this, we can't just calculate missing side lengths because there's not really a lot of rhyme or reason to it. But our regular polygons, we can. And triangles, we can. There's certain polygons that we can work with if we only know, limited information. For instance, let's look at a triangle. Now, certain triangles, like a scalene triangle where all the sides are different, you still just have to know the sides, okay? So that one I'm not worried about. It's similar to what we just did. But right triangles, if I only know 2 of the sides, I can still find the third and then add them up. Okay, so if I knew, let's say I knew the 2 legs were, let's go with 6 inches and 8 inches, then I could find the third one and then add them to get the perimeter by using Pythagorean theorem. Remember, if this is side A, side B, and side C, we know that a squared plus b squared equals c squared. A is 6, b is 8, c we don't know. So what we're doing is finding the third side before we find the perimeter. Okay, 6 squared is 36, 8 squared is 64, their sum is 100, and we need to take the square root of 100 in order to find the value for the hypotenuse, which is 10. Okay, so we have a 10-inch hypotenuse, and then the perimeter is simply the sum of 6, 8, and 10. 6 and 8 make 14. Add the 10 and you get a 24-inch perimeter. Now the thing about perimeters, their units are always in units of length. Inches, feet, meters, kilometers, those sorts of things. So they're always measured in units of length. In fact, maybe I'll put that up here. Measured in units of length. Okay? So just keep that in mind. Now, other regular polygons have some nice formulas to them, particularly if you only needed or if you only knew a handful of the sides, okay, you can kind of figure out the rest of them. For instance, a square. A square is a quadrilateral because it has 4 sides, where all the sides are equal. Okay, so if you know one side, you know all the sides on a square. I'll call the side S on a square. I don't know if it's S for side or S for square, but either way, it's S. Then the perimeter is found by just adding S plus S plus S plus S. They'd all be the same, right? But who wants to add 4 things together when you could just multiply one of them by 4, right? So if I had a square of side length 11 feet, then I know the perimeter is going to be 4 times 11, which is 44 feet. Okay, so rather than adding 11 plus 11 plus 11 plus 11, right? So that's a square. A rectangle is another nice polygon, quadrilateral in particular. Change up the color here. A rectangle, like a square, has all 90-degree corners, but it only has opposite sides equal to each other, okay, or equal in length. And so we call those, typically we call them the length and the width of the rectangle. There are other words we can use to express those, but I'll call them length and width, L and W. And so the perimeter could be found by taking a length plus the length, because the opposite sides are the same, plus the width plus the width. But by combining like terms, I can just make that a little bit nicer of a formula and call it 2L plus 2W. So if I know the length and width, I just double each of them and add them together. I could just add them all together. Either way is fine. So if I knew that the width was 5 feet and the length was 8 feet, then I just double each of them and add them up. So the perimeter is 2 times 8 plus 2 times 5, which is 16 plus 10, which is 26 feet. Okay. Again, you could just do 5 plus 5 plus 8 plus 8. Okay. Same way, or same result. Okay, so those are rectangles. And of course, we can construct other shapes or other polygons using these shapes. So we could have like weird rectangular objects, like everything's got 90-degree angles on it. Right, something like this. And I need a handful of measurements or lengths to find the rest. So for instance, basically I group these together. They're vertical and horizontal sides. The vertical sides, basically if you have one long vertical side, all the other ones will add up to it, right? And if you have, well, I don't have one long horizontal side, but you can see the 2 on the bottom here go across together. They span the whole object. The 2 on the top span the whole object. So together, the sum of those 2 must equal the sum of those 2. Okay. So that's kind of nice. At least we can separate things, break them down. Let's throw some values on here. Like maybe this is, I don't know. Maybe this is 2 inches. And this is 2 inches down here, and let's make, so I do have to know most of the sides, okay, but we might be able to get by without knowing all of them. Maybe this long one here is 5 inches, and this one is 4, let's do the long one here is maybe 9 inches. Yeah, let's go 9 on that one. And let's put one up here on the top. Let's make that 3 inches there. Okay, I think I like that. And so to find the perimeter, this is let's see how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8 sides. And I know 1, 2, 3, 4, 5, 6, so I'm missing 2 of them. And those 2 can be found, again, because I know, let's look at the vertical ones. This first one, I'll call it V for vertical, and maybe the other one I'll call it H for horizontal, okay? The vertical one I know is found because I can take 2 plus 4 plus V, and that should equal 9 on this. They should span the whole height of the object. So 2 plus 4 plus V equals 9. To find V, I add those up and subtract them from the 9. So V is equal to 3. Okay, so I know that one. And then the H, well, I know that the 2 horizontal on the bottom should equal the 2 horizontal on the top, because both pairs span the object. So I know that 3 plus H should equal 2 plus 5. Sometimes you have to get a little bit creative with these. So I get 3 plus H is equal to 7. Subtract the 3 from both sides, and H is equal to 4. Okay, so there's 4 inches there. And now my sum, my perimeter, is the sum of all 8 of these sides. So the perimeter, I'll just work around here. 2 plus 2 plus 5 plus 4 plus 4 plus 3 plus 3 plus 9. Okay, that's kind of going around counterclockwise from the bottom. And if I group these together, let's see, 3 and 3 makes 6, and 4, that makes a 10. Doesn't look like a 10, that's 10. Let's see, 2, 4, 8, 8 and 5 makes 13. So these together make 13. And then I've got my 9. 13 and 10 make 23, and 9 makes 32 inches. All right. Cool. That'll work. Another thing you can do on a rectangular solid like this is take the total height and double it. Take the total length and double it, and you should get the same answer, which is kind of a neat idea. It's a little bit simpler. Yeah, so I could have actually done this right off the bat, because the 9, if I double it, I get 18. If I take the total length, that's 2 plus 5 is 7, double it, you get 14. And if I add the 18 and the 14 together, I still get the 32. So an alternate method, instead of having to find every side and add them up, if you know enough information to get the total vertical distance and the total horizontal distance, you can double each one, just like the formula for a rectangle. Basically all we're doing is we're taking the big rectangle and we're moving some of the sides around, or parts of the sides, right? So if you imagine this filling in to one big rectangle, I took the side H and just moved it from the top down, side V, and put it over here, this 5 down here, and the 2 came over. And so really, if you moved everything back to the exterior of that rectangle, you get the same perimeter formula. So if you just double the long side vertically, double the total horizontal length, it's just like doubling the length and the width. So just an alternate method that would work on a rectangular object. Not an actual rectangle, but a shape made up of rectangles.